Hello class, today we're going to be covering 9.6, which is solving nonlinear systems of equations. So basically what we mean by that is they're going to give you two equations. One of them is going to be linear, so it's going to be a line, and one of them is going to be a quadratic. And so basically what they want you to do is they want you to see where do they cross. What is the point, or plural points, because there could be more than one, of intersection. So I'm going to come back up to this one in just a second, but I basically want you just to go down here because this is a really nice graphic. As you can see here, there's a line in each one of these, and then there's also a parabola. So you can tell that when a line and a parabola interact with each other, there's three different possible solutions that could occur. They may not cross at all, so you'd have a no solution. They may simply touch at like one point, so you would have one solution, or the line may cross right through it, so you would have two solutions, those two places. So what they're going to be looking for today is an ordered pair, like x comma y. So they want these to be numbers. Obviously, if it doesn't cross, you can simply say no solution, so you can say ns. But if there's two solutions, then you're going to have to list two different x, y intersects. So we're going to need these today as an ordered pair, okay? Now, methods. The methods that we have here are really the same that you had when you did systems of equations back in Algebra A. So our methods are graphing, substitution, and elimination. Now, if we were in class, typically we would have you try like a few problems with each method. So we might have you do two of each of these. But because we're not there and the exit quizzes don't really allow for us to type in our work, honestly, you can really pick whichever one you want, okay? So pick a method. What I'm going to do here is I'm going to show you one of each of these just so you're kind of exposed to it and that you maybe would recognize it in another class. But again, it's really totally up to you because how am I going to know which one you pick, okay? So let me show you graphing. So if we go up here to this first one, graphing, I'm going to do this first one. We'll call this number 1. I'm going to do this in blue. Okay, so just so we can see it a little easier, it's y equals x plus 2. This is in slope-intercept form. So what I'm going to do is just go up to 2 and put a dot, and then I'm going to do my slope, which is up 1 over 1, up 1 over 1. And you know what? I'm going to go the other way just so that I kind of get a good, nice straight line. And of course, I don't have a ruler handy here, but I do have like a pad of paper. So I can just use kind of the edge of this pad of paper. And I'm going to draw myself a nice straight line as best I can. And so that is my first one. That's my linear line. Now my second equation here, so let's call this number 2. My second equation is a parabola. So a parabola, I can't use slope-intercept. So I need to think back to our previous chapters or our previous lessons, and I need to think about, okay, how do I graph this? And so if I was there with you, a couple things I would ask is where do we start? And so maybe somebody would throw out the vertex. Well, how about we calculate the vertex? Where's the turning point? And so because this is in standard form, you have to remember the formula is opposite b over 2a. So this is our A, our B, and then there is no C value, but we don't have to worry about that because it's not part of the formula anyways. So if we do our formula here, opposite B over 2 times A, that's negative 2 divided by 2, so that's negative 1. And then just so, again, you don't think I'm doing anything fancy here, if you want to grab a calculator, all you really have to do is plug this negative 1 back into the original. So you just make sure you put it in parentheses. Okay, and then 2 times negative 1. So you just plug it back in. So my vertex is negative 1, 1. So that would be right here. That's my vertex. Now I would ask you, how do we know more about this parabola? And so somebody might say, well, A is positive, so we know it opens up. So we know it opens up, which is good. That's true. But how do we know how wide to draw this? So somebody else might say, how about we find the x-intercepts? So if we were to find the x-intercepts of this equation, we would have to set it equal to 0. So we'd set this equal to 0. And then we would have to do the greatest common factor. So we would pull out the x. And then what are we left with? So this kind of takes you back to your chapter 7. Okay? And then we just set each of these equal to 0. So we have 0 equals x. And then we have x plus 2 equals 0. And then we have x to be negative 2. So we know it's going to cross at negative 2, and we know it's going to cross at 0. So let me put those dots on there. Oh, wait a minute. I can already see right there, if I were to draw this side of the parabola in, do you notice that's where they cross? You see they're crossing right there. So I know that one of the answers must be negative 2, 0. I know that one because I can physically see it. But over here, it doesn't cross yet. And so if I just hand draw this in, what if I connect, and then what if I go too straight? Or what if I don't go wide enough? And so that's where this kind of graphing by hand can be very, very difficult. But what I would need to do, honestly, is just take my equation. Okay, so I'm going to write it right here, y equals x squared plus 2x. And I would literally go old school, and I would start plugging values in. I already know this is a 0, but what about when x is 1? So if I plug 1 in here, I get 1 plus 2, that would be 3. So at 1, I get a 3. And look at, that's where they cross. Now if you want, I can plug more points in. I can plug 2 in. If I plug 2 in, that would be 2 squared is 4 plus 2 times 2. So I'd get 4 plus 4, which would be 8. So 2 would go all the way up to 8. So it would look like that. And now I can see that it crosses right there at 1, 3. Now, notice I used my calculator when I typed this part in, but I really didn't need to. I really could have done this without a calculator. The problem is if you don't have this exact grid with all these little lines, this would be difficult because it would be hard to do this straight, to know the slope and things like that. So doing it by hand, graphing, can be difficult. Let me show you in the graphing calculator. Again, some of you may not have your graphing calculator at home. You can go online and try to pull up the Texas Instrument, just a free one. Don't go to Desmos right now. We'll talk about Desmos in just a second. But let's just see if we type them into the graphing calculator. And now we hit graph. And you're going to see the line coming in first. And then you'll see our parabola. And sometimes you can, again, see the answer. Like you can kind of see that answer right there, the negative 2, 1. But maybe our eyes aren't so good for this other point. So if you're trying to find this other point, remember, you can always go second, calculate, and then you go down to the word intersect. And then you just have to move the star close, because if you try to put it kind of in the middle, it might get confused which side you want. So what I usually do is just move it kind of close. It doesn't have to be dead on, but I just move it close. And then you hit enter 3 times. So 1, 2, 3. And notice right at the bottom of your screen there, it'll give you the answer, 1, 3. And if you did want to find this other intersection, you just have to go second, calculate, intersect. And now when you see the blinking star, you just have to move it over to the other side. Because maybe it's a decimal. Maybe this really wasn't negative 2. Maybe it's negative 1.96. So if you want to be accurate, just move your star and then enter 3 times. 1, 2, 3. And then you'll see again the answer shows up at the bottom of your screen. So honestly, I do really like the method of graphing. I would, caution you on trying to use Desmos too much in this lesson because you're not going to have Desmos on your SAT. You can have your graphing calculator on the SAT for most of it, but you're definitely not going to have Desmos. So let's just stay away from that one for a second, okay? So I showed you the method of graphing. Now, if you notice, I've just got some more problems down here. What I'd like to do is just show you, another method. So let me show you the method of substitution. And I really like substitution on this because do you notice how they're both equal, y equal? So essentially what I'm going to do is I'm going to take this out and I'm going to put this one right in its spot. So I'm just replacing it. So I'm going to rewrite this. So I have the new one on the left, and then I have the trinomial on the right. And now if you notice here, this is a quadratic. So what you're going to need to do is move everything to one side. So how about we'll subtract the 3x. So that's going to leave us with, well look, those cancel. How nice is that? -5. Now let me just think about this for a second. I don't have a middle term, do I? So because I don't have a middle term anymore, I really don't want to move this 1 over here. Because let me write in pencil. Watch if I move the 1 over. Do you see that? Now what am I going to have to do to solve this? I could factor. I could go like this. And that's x times x. And that makes my signs alternate. And I get 2 times 2. And then now I just set each piece equal to 0. So I go 0 is equal to x plus 2, and 0 is equal to x minus 2. And then I just solve these. And then I add the 2. And this is perfectly fine. There's nothing wrong with this. But that kind of seems like a lot of writing and a lot of work. For what if I would have just moved the 5 over? Do you see if I would have just moved the 5 over? I get -1 plus 5 is 4 equals x squared. And then couldn't I just take the square root of both sides? And don't I get plus or minus 2? Isn't that the same thing I got down here? Okay, so it's really ultimately kind of up to you. Remember, math, you always get to the same answer, but how you get there could be slightly different. Now, we do have to give these as ordered pairs as we set up here. So what we need to do is we need to say +2, comma what, and -2, comma what. And so what you do is you take your x value and you plug it back in. Let's use the first equation, let's use the linear one, and then I'll show you the second one as well. So if I plug the 2 in, 3 times 2 is 6, 6 minus 1, there's my intersection point. Let's plug -2 in. 3 times -2 is -6 minus 1. There we go. Now let me show you in my calculator here, if we were to take those same numbers and we're going to plug them into the second equation. So I'm going to take the 2 and I'm going to plug it into the quadratic. See how I'm plugging it into the quadratic? Look it, I got the same number. Let's try the next one. Let's plug -2 into the quadratic. Look it, I got the same number. So basically what I'm trying to show you here is it does not matter which equation you plug them back into. I usually go with the linear one just because it's a little easier to do in your head, but it's totally up to you. I just want to show you that you can, do either one. So this would be how we use substitution, okay? And I would probably say that substitution is very common, especially if you were on a no calculator. So what if you couldn't use your graphing calculator and you couldn't type them in right here? Substitution is very, very common. Let me show you elimination. Now, elimination is going to be a little bit difficult on this one, but I'm going to go ahead and show it to you. Again, it is not my preferred method. I can do it, but I actually find it to be sometimes a little bit more challenging. Now, in elimination, you want them to be lined up. So this is looking pretty good. The only thing that's kind of tricky is there's no x squared right here. So I'm going to just take the time here to rewrite this. So I'm going to go y equals 0x squared minus 6x plus 14. Because do you see how I want them exactly lined up? Okay? Now, With elimination, you have to ask yourself, if I was to add these equations together, would I get rid of a letter? And the answer is no. Because watch, if I add them together, if I were to add, this would become a 2y, this would become an x squared, a minus 15x, and a plus 30. Did I get rid of a variable? And the answer is no. So instead of adding, you would actually want to subtract. So if we were to subtract y minus y, we would get 0. And then x squared minus 0, so you just get x squared. Now you do have to be careful here. You have a negative 9 minus a negative 6. So you're going to end up zip-zapping here. So that would really be negative 9 plus 6, which is a negative, good thing I'm in pencil here, a negative 3x. And then we're going to go 16 minus 14, which is 2. Now, do you notice that this is a trinomial? Over here, do you notice we did not have that middle term? See how our middle term canceled? That made it significantly easier, but do you notice I still could have factored? This one is a trinomial. So you either have to factor or you're going to have to run the quadratic, complete the square. You're going to have to do something. So let me show you if you were going to try to factor. So let's say you want to go back to your chapter 7. You want to go back to that technique and you're going to try to factor this. You're going to use x times x. Now 2 is prime, so you only have one option, 2 and 1. And this is going to tell you your signs alternate. Okay, actually, sorry, that's a plus. My eyes just caught that. 16 minus 14 is a plus 2. So actually, this is going to tell me that my signs alternate like that. Okay? And so now if I check the outer, I get a negative 1, and the inner is a negative 2. Hey, there's my negative 3. So do you notice how this was not all that hard? Let me write that down. This was not actually all that bad to factor. So now that I have this, I've set each piece equal to 0. And so I'm going to add 2 to the other side. And I'm going to add 1. Now notice those are only my x values. So this is going to cross at 2, but we're going to need to get the y value. And then this is going to cross at 1, but I need to get the y value. Now remember, you can plug these in to whichever equation you want, but preferably I would probably go with the bottom one, the linear one in this case. So if I plug 2 in, that would be negative 6 times 2. So that's negative 12 plus 14. So that would just be 2. And then if I take and plug the 1 in, so if I go negative 6 times 1 plus 14, that would give me 8. And so these are the 2 places where it crosses, okay? So I have showed you an example of each one. I have showed you graphing, but again, graphing by hand, unless you have a grid, can be hard. I have showed you substitution, and I have showed you elimination. Now, I have about 4 more problems here that I definitely kind of want to show because there are some tricks with some of them. So there's number 4, and then I've got 3 more on a separate page here. I wish we were together so that I could pick on somebody and say, like, Morgan, what method would you like me to show? But since I'm sitting here all by myself, it's kind of difficult to know what everybody would pick. I think there's a lot of people who are probably going to pick graphing just because it is a very common one. So why don't you pause the video here and why don't you try this next one and just pick whichever method you want and then we'll come back together. All right, again, I wish I was there. I wish I could help you, but this one was a no solution. Okay, let me just quick show, since I'm not there, we're not together, I would probably use substitution. I would probably take this and plug it right in its place. So I would do x minus 3 is equal to x squared like that. And then I would move both of these two to the right. So I would subtract the x and I would add the 3. So I would get x squared minus x plus 3. Now from here, I may try to factor this. I may try to go like this. And I would get x times x and 1 times 3. And this tells me my signs are both the same and they're both subtractions. But I have a problem. That's the wrong middle term. Do you see how that's a negative 4x? That's not the right middle term. But there's no other way to do this because 3 is prime. So now I'm like stuck. And so what do I do now? So now maybe you go to your graph. Maybe you go to the graph and you type it in right here. And you see x minus 3 and then you see x squared and you hit graph and you watch it. And here comes the line. And then here comes the parabola. And do you notice that they never cross each other? They never cross. So then you know it's a no solution, okay? Let me show you one other one. Let's say you were on a no calculator part of a test and you're like, oh no, I can't type them in my calculator. Well, you could try to sketch it by hand. I mean, you could try to sketch it, but you could also just do the discriminant, the b squared minus 4ac. So you have your a, your b, and your c. So if you do b squared minus 4 times a times c, you'll get positive 1 minus 12, which is negative 11. Remember, in the quadratic formula, opposite b plus or minus the square root. Can you have a negative underneath the square root? And that's how you get a no solution. So please, please know that these can be done by hand. However, technology, if it's available, definitely is faster, okay? So take a look at these other 3, and remember, these are all also posted on the main website, so if you have trouble seeing them, that's okay. I wanted just to point out a couple things on these ones. Number 5, the reason why I wanted to point this one out is, do you see the second equation? If you are someone who likes substitution, this one would be a little tricky. If you're going to type it into your calculator under this part, you're going to need to move this 4 to the other side. So let me just show a couple quick steps here. I'm going to kind of show both methods. So if you're going to use substitution and you take this part, you would put it right in place of the y. So it would look like this. X minus 4 in place of the y, then you still have to do the plus 4, and then you have x squared plus 3x. Do you see how, again, I just had to replace that front part. Now these would cancel each other out, so you would just have x equals x squared plus 3x. Then I would move this single x to the other side. So I would get 0 equals x squared plus 2x. Now, this is only 2 terms, and there's no constant. So I would just pull out the greatest common factor if it was me. So I would go x, and then what are you left with? And then you set each piece equal to 0. So you have negative 2 is equal to x, and x is 0. Now you do have to plug those back in. So you have 0, you got to figure out the y, and then negative 2, and then you got to figure out the y. So let me quick plug those back in. That would be a negative 4, and that would be a negative 6, okay? Now, if you are someone who you're like, nope, Mrs. Twig, I'm typing these into my graphing calculator, okay, we can do that too. The first one would be fine. So a number 5, that would be fine. X minus 4, you could just simply take that one in. But in the second equation, you would have to move this 4 over here. So you'd have to subtract the 4. So you would get x squared plus 3x minus 4. And then you could go to your graphing calculator. Like that. And then you could hit graph. And you'll see them crossing. The graphing calculator is pretty fast, but it does take it a second because it's, trying to do the slope and it's trying to do everything. Now, this one right here is pretty easy to see because it's right on the axis. But this one on the left, I don't know that I would trust my eyes. So this one on the left, I definitely would probably go through and go second, calculate, intersect, and I would move that blinking star over here, and then I would hit enter 3 times. And now you can see the intersection was -2, -6. Okay, so again, I just wanted to point that out to you because I thought it was kind of unique how this was not in a y equals. All right. Another one I just wanted to point out to you was number 6, because do you notice how this is a constant? I wish we were there together because one of the questions I'd ask you is, what does this look like? And you should all tell me that it's a horizontal line. So it's a horizontal line at 6, like that. So this is still linear. It is still linear. Now you just need to see where this parabola comes in. I can roughly tell you that this is going to move it up 2, and then it's going to go like this because it's positive. But where exactly these points are, one is positive and one is negative. Now, the other thing I can tell you is look at the y value. So the y value is going to be 6. The y value is going to be 6. I just need to know what the x value is. So again, it would not be very hard to do substitution, to just take this 6 and plug it right in there. So you'd have 6 is equal to x squared plus 2. You would subtract the 2, and you would take the square root. So you get +2 and -2, and you would be done. But I just wanted to show you one that is a constant instead of kind of like slope-intercept form, because sometimes we look at this and we get, well, what am I supposed to do? This is still linear. We just don't have a slope. Really, our slope is 0, and that's okay. Now, if you notice, they do not give you one that is an x equals. They don't give you an x equals because x equals, so if you have like x equals 3, that is a vertical line. Vertical lines are not considered linear, so they don't give you any of those. Now, you might get that in Algebra 2, though, so be careful, okay? Now, number 7 is really not anything tricky. It was just another problem in the student journal, so I threw it on there. So if you would like to type that in your calculator, or if you want to pause the video here, go ahead. So if you pause the video and you tried it, the only thing unique about number 7 is actually there's only one answer. So it only comes out to cross at one place. Again, if it was me, if I was doing this, I would take the x squared and I would plug it in right there. So I would have x squared is equal to 2x minus 1. I like my x squared positive, so I would move both of these to the left. So I would subtract the 2x, because see how it's positive, so I would subtract. And then I would add the 1. So it looks like that. And then if you want to try to factor, you have x times x. 1 is prime, so it's just 1 times 1. This tells me my symbols are the same, so when I look back, they're both subtractions. And what do you notice? We call this a repeated root, which basically means instead of having 2 different answers like this, we just have 1. So x minus 1 is equal to 0, and we move the 1 over. And so notice, that's how I got the x. And then you can just plug that back in. Or plug it in here, 1 squared is 1. So that's why we only have one solution there, okay? And that concludes our chapter 9. We will do an extension lesson. Our extension for chapter 9, so the extension lesson for chapter 9 is going to be going over some story problems, because we haven't been doing any story problems, and as you know, those are very commonly tested. So that will be our extension lesson, and I hope everyone is doing great.